Hello, my name is Sigal Ben Yehuda, and I'm a researcher at the Hebrew University of Jerusalem in Israel. In our paper, published in this issue of Cell, we provide evidence for a novel type of bacterial communication that is mediated by intercellular nanotubes.
We show in our work that adjacent cells can exchange cytoplasmic contents such as small molecules, proteins, and even non-conjugative plasmids.
The first observation that actually supported this idea was the following. When we spotted side by side two B-Satellite strains, one expressing cytoplasmic GFP and other that doesn't, we were able to see a fluorescent gradient emanating from the GFP plus producers and extending towards the non-labeled cells. When we zoomed in into a single cell level, we were able to see that the GFP minus cells lying close to the GFP plus cells acquired a weak fluorescent signal over time. Thus, it seems that cytoplasmic molecules can be transferred between neighboring cells. Moreover, we're able to see the exchange of antibiotic-resistant proteins among the cells, as well as the transfer of non-conjugative plasmids. This led us to the question if we can actually observe physical connection between the cells. Is there any apparatus that can facilitate this process? To answer this question, we did the following. We spotted B-Satellite cells at the logarithmic phase on an LB agar plate. We placed EM grids on the top of the cells and let them grow for 3 to 4 hours. Then we lifted up the grids and observed the cell by scanning electron microscopy.
Remarkably, we immediately noticed the protrusions that are projected from the cells, connecting them one to the other.
Here you can see a clear view of a network formed by these tubes, which we call nanotubes. The size of the tubes was variable and dependent on the distance between the cells. The length could reach approximately 1 micron, while the width was around 40 to 120 nanometers. Using immuno-EM with antibodies against GFP, we're able to see a clear GFP signal that colocalized with the tenol. You can see here the molecules of GFP moving from one cell to the other. An important perspective of our finding was to investigate whether the exchange of cytoplasmic molecules, as well as the formation of intercellular nanotubes, occurs between species.
To explore this possibility, we first investigated the ability of B-Satellite cells to transfer cytoplasmic GFP molecules to the gram-positive bacterium Staphylococcus aureus. To our great surprise, we observed the transfer of GFP molecules from bacills to staph.
We are also able to see visible nanotubes that are formed between staph and bacillus, and even between bacillus and the gram-negative bacterium E. coli.
We believe that communication via nanotubes enable bacteria in nature to acquire new features such as resistance to drugs.
Thus, we show in our paper that bacteria are much more social than previously estimated, and they are able to exchange cytoplasmic molecules within the same species and in between species. Thank you for watching us. We hope you will enjoy reading our paper.